Good evening, sir. I hope I'm audible.
Yes, madam.
So, shall I start or do I need to wait? Okay, sir. Good evening, everyone.
Good evening, ma'am.
Good evening, ma'am. So, I hope the concepts I discussed yesterday are clear to everyone. Yes. I hope I'm audible.
Yes, ma'am.
Okay. What about the others?
Yes, ma'am.
It's clear.
Yes, ma'am. You are clearly audible.
Okay, fine. So, today I'm going to start with the T test, right? Give me a second. I think I have not shared my screen. Not I have switched on my video also. I hope. Yeah. Fine. So yesterday I talked about the chi-square test, which was the non-parametric test. We have seen that how we can perform chi-square test using R. There I have explained you the two varieties of chi-square test, that is the goodness of fit and the independence of attributes, right? Today I'll talk about the t-test. Give me a second. I'm going to share my screen.
Ma'am, I have a question actually.
Yes, ma'am.
Ma'am, regarding the questions you shared for the probability distribution, I have a question to ask, if I may.
Okay.
Ma'am, there was a question related to that there is a range of value. What is the probability related to the blood pressure? If I could post it on the message, if you could read that.
Okay, fine.
Yeah, this question is actually given to in the exercise. Posted it.
Fine.
So basically, it's a normal distribution given to us with a mean and a standard deviation.
Yes.
So it's a variant of norm actually, which we'll use basically. Ma'am, but the probability should be between 110 and 140, right? So basically, we are including 110 and 140 also, no? I mean, in this question,
you are using P norm, right?
Yeah.
Okay, fine. And in
So
P norm, what parameters you are putting?
That's what I'm trying to ask, ma'am. I'm not able to decipher the complete answer to this question actually. I mean, I have got the answer, but I just need to confirm what is the correct
So,
answer.
what can you tell me the syntax you have written?
So, ma'am, basically, I'm just a bit confused regarding like 110 we are including or not. I'm just asking that. It's between 110 and 140.
So, you are asking for that F and T. This is what you are saying?
No, actually, in first, it's like 100. It should be greater than equal to 110 and less than 140. Is that the logic which we'll apply?
Obviously. Means up to 110 you will calculate, and up to 140 you will calculate, and then you will subtract 140.
40 till 110. Okay, ma'am.
Yes.
Okay.
Yes.
Thank you, ma'am. Thank you.
Yes.
So, ma'am, do we put a plus sign between these two?
Minus. Subtract. We will subtract. We need a between, no? So if we are putting 140, it will give me the probability till 140. Then it will be giving the probability till 110. Then I'll subtract from 140 to 110. So this way, it will return me the remaining probability.
Thank you, ma'am. Thanks a lot, ma'am.
Yeah, thank you, ma'am.
So, ma'am, if I can just confirm, it should be like P norm 140, 120, 15T minus P norm 110. Right? And that will give us the final for
final answer.
110 to 40.
Yes. Correct. Correct, sir.
Then similarly,
Yes,
if there
thank
is
you.
for temperature, then also we will do P norm for high minus P norm for low temperature
Yes.
to get the P norm for that range.
Correct, sir.
Okay, ma'am. Thank you, ma'am.
Thank you, sir. Okay. So shall I proceed or any other question? Okay, I hope no questions. So okay, I'm proceeding. Okay. So I'll talk about today the t-test, right? I'm clearing my environment, my everything here, right? Today I'll talk about the t-test. Before talking about the t-test, I'll talk firstly about the parametric test. Yesterday, I think I explained you when we talk about the non-parametric test, that way we are considering or we are talking about the categorical variable. And when we are not bothering about the normal distribution, this way or this is the way to decide upon the parametric and non-parametric test, right? So when we are dealing with the continuous variable, it is always required to check its normality. And that way we need to decide upon the test which is coming from the parametric test category. So parametric tests are the tests which consider the normal distribution of the population, and these tests are generally based on the continuous variable. And also, if I talk about parametric tests, so using parametric tests, we are trying to infer about the population parameters using sample statistic, right? This is known as the parametric test. Yesterday, I think one of you have given some of the names of this particular category, t-test, z-test, etc. So one of the tests I am picking today, that is the t-test. So today I'll firstly talk about the concept of t-test, right? So if when I say it's t-test, give me a second. I'm saying when I'm saying, just a minute, the t-test, yeah. So purpose of t-test was to find the significant mean difference, right? Means whenever we want to compare continuous variable in the two groups. So that means I am interested in comparing the mean of the particular. I'm comparing. Give me a second. Give me a second. Just a minute. Just a minute. Yes. Sorry, there was someone on my cabin. Just a minute. Yes. So I was talking about the t-test. So I said when we want to compare the mean of the continuous variable in the two groups, in that case we are talking about or we are interested, or we can say this is the test which we are generally saying to apply, right? So whenever you want to compare the mean difference, you are using the t-test, right? Now, there are various things you need to keep in your mind while deciding the t-test. The very first thing is, when we talk about the t-test, firstly, there are various different categories are available in t-test. Those who are knowing, they are knowing there is one sample t-test. Then there is two samples t-test. And in this category, we can keep two more, or we can bifurcate this into the two more t-tests. That is the independent samples t-test and dependent samples t-test, right? Further, Further, I'll talk about firstly the one sample t-test, right? From name, it is clear one sample t-test means when we are having only the single sample, right? So I can say this thing because generally for formulating our hypothesis, we are requiring the two variables, right? But when I'm saying one sample t-test, that means I'm having only a one single sample or one single variable, right? So how I'll formulate my hypothesis? For that, generally, what we are saying, we are interested to compare the sample mean from the population mean. Means we want to see this thing that whether the sample is belonging to the population or not, whether the sample is coming from that population or not, right? So that way we are comparing the population mean and the sample mean, and that way we are using the one sample t-test, right? Now, there are certain assumptions. I think previously also I mentioned usually in statistics there are certain assumptions for the statistical test. So once I'm talking about the one sample t-test, assumptions are, first is there should be one categorical variable. Sorry, there should be one continuous variable, right? Next, there should be no outliers in the variable. Next, the variable should be normally distributed. So these are the assumptions which you generally need to test, and then we will apply the one sample t-test. So the concept of one sample t-test is very simple. That means whenever you are interested to compare the significant mean difference of sample and population, you are using one sample t-test. And in case of t-test, you need to have the continuous variable, that is the numeric variables you need to have. Means here there is no role of the categorical variable, right? Whatever variable you are considering, you need to see whether the variable is normally distributed or not, and it should not contain any outlier, right? If it is the case, in that case, we can apply the one sample t. I hope it is clear.
Yes, ma'am.
Fine. We will take one example now for this. Suppose I am taking a IQ score, suppose, of 20 people, suppose, and I want to test whether the sample is belonging to a population whose mean IQ is 100, right? Means I will collect the IQ score of the 20 people, right? And then what I'll do, I will check the mean IQ of those 20 people is similar to that 100 or not, or is there any variation is coming. So that way I will test a hypothesis. So I hope case is clear.
Yes, ma'am.
So here I am writing my hypothesis. There is no significant difference in the mean IQ of sample and population. This will be the null hypothesis, right? Alternatively, I think this is the first time I'm writing a parametric hypothesis, so I'm writing the alternative hypothesis as well. Here I need to remove this no and I'll make it 1. So it is there is a significant difference in the mean IQ of sample and population, right? Is it clear?
Yes, ma'am.
Now, before performing a t-test, firstly you need to test the assumptions as well. Firstly, you need to test the assumptions as well, but before that, we need to have the data, right? So here I'm creating a vector firstly. Suppose I'm creating a vector of IQ. So using a C function, I'll enter the certain values of IQ. IQ is nothing but it is an intelligence quotient, right? So suppose I'm entering some of the figures like 102, 98, 105, 101, 99, 108, 102, 104, 102 again, 106, 107, then 101, 99, 98, then 103, 101, 102, likewise. I don't know how much values are entered. I am pressing Control Enter or running this, and then I'm checking the length, whether I entered 20 figures or not. 19. I need to enter one more. So suppose I am entering 104. Done, everyone? Do I need to copy and paste this in the chat?
Yes, ma'am.
Yeah, I'm doing. Give me a second. Okay, I pasted. I hope you got it right.
Yes, ma'am.
Yes, ma'am.
Fine. So we'll proceed. If you copy and paste it. Now, next thing what we need to do is this. We will check the assumptions first, right? So if I talk about the very first assumption is very simple, which is saying your variable should be continuous. So we can say it's a numeric variable, it's a continuous variable. IQ can be in the decimal points also. So the nature of variable is continuous or numeric. So that way, first assumption we check, it is generally we checked using our own information of our own observation, right? Second is you need to check the outliers in the normal distribution of the IQ, right? So for normality, generally I'm writing the hypothesis of normality, which is the variable is normally distributed. This is what the hypothesis is, right? How you can check this? There are certain graphical methods and numerical methods. Both are available. Using that, we can check the normality. So I'm writing the name. Name is Shapiro.test. This function you can use, or QQnorm, and I think it's QQline that you need to use, right? Using these functions, this is the numeric method, the first one. Second two, which I have written, these are the graphical methods. Using that, you can check the normality of your variable, right? So I'm using firstly the first method, that is Shapiro.test. Right now, inside this, I need to pass the name of my variable and I can run this. I hope it is fine. May I?
Yes, ma'am.
Yes. So we are getting the output. This I am pasting the output here, which is the W Shapiro-Wilks. This is Shapiro-Wilks. It is given. This value is given by W, and this is its p value, right? So if I will look at the p value, so p value is what it is. It is Anyone?
0.6.
0.0.
It is greater than 0.05.
0.0.
Right? So what decision I'll take?
Accept the null hypothesis.
Accept null hypothesis. And if I'm accepting the null hypothesis, that means I'm saying my variable, that is IQ, is normally distributed. Right? Clear?
Yes, ma'am.
Now we'll go with the second testing using the graphical method, QQ norm. Inside that, you need to pass the name of your variable and you need to press Control Enter. Done?
Yes, ma'am.
So I hope you can see the diagram coming in the fourth window, which is indicating this is the distribution of the IQ values, right? Theoretical quantiles or quantities, theoretical values and the sample values are distributed like this. You need to see whether this is normally distributed or not. So you can fit a line, that is QQ line. Inside that also you need to pass the name of your variable. And then you need to press Control Enter. Now you can see this is a fitted line. So this fitted line is what? This is indicating whether your data points are following the line or not. So many of the data points are almost nearby the line, but few are the values which are little deviating from the line, right? So this way we can say IQ is approximately normally distributed, right? If all these points, these three and these 2 points, if they will more close to the line, that means your data is almost following the normal distribution. Is it clear?
Yes, ma'am.
Fine. We'll check.
Yes, ma'am.
Yeah. We'll check the next assumption, which is the assumption of outlier. So to test this, you need to now, okay, just a minute. Fine. So to test this, you need to use box plot. I don't know how many of you are aware of the concept of box plot. Yes. Right. So for box plot, you need to use the function box plot only. Right. Now, I'm using the function box plot using the name of my vector inside the box plot and pressing Control Enter. In the fourth window, you can see we are able to get the depiction of box plot. I hope everyone has able to make it. Done?
Yes, ma'am.
Suppose inside this, I am passing the name. There is some problem with my laptop. Done. So this will give me the title of my box plot, right? So how to identify whether the outliers are there or not? So first you need to see the components of box plot. So if I talk about the components of box plot, it is having the 5 components. It is having 5 components named as median, which is the middle line of this box. This the darker line, middle the box. This you can say this is the median line. Then the lower line of this box, this one, right? This is known as the Q1, and the upper line of the box is known as the Q3, quartile 1 and quartile 2. And apart from that, this particular area is known as upper whisker and this area is known as lower whisker, right? So lower whisker and upper whisker. Fine, everyone? Now, to understand,
Excuse me, this whisker, lower whisker and upper whisker means can we name as quartile, lower quartile and upper quartile, same as?
sorry?
Here, madam, you have written lower whisker and upper whisker. It is different to lower quartile and upper quartile, madam?
Lower quartile.
Yeah, lower quartile. Q1 generally we
Obviously,
name
this
as
is the lower
quartile.
quartile. It is obviously, sir. This is the Q1. So the value which are below the Q1, they will come here. The values which are above the Q3, they will come here. So this zone,
What
this
is lower
area is known
whisker
as,
and upper whisker, madam?
this is what I'm telling. This area is known as lower whisker. Q3 minus 1.5 IQR. IQR is known as this lower whisker.
Oh, okay. Thank you.
Now, if any of the circles we are getting above and below the lower and upper whisker, that way it is indicating that the outlier is available in your data, right? But you can find above and beyond the whiskers, we are not getting any circles. That means our IQ variable is not containing any outlier, right? Is it clear? Is it clear?
Ma'am, could you please repeat the IQR part of lower and upper whisker ones, please?
It's Q3 minus Q1.
Okay, like 1.5 into IQR, so that.
I'm not getting, sir. What you are asking?
Q1 minus 1.5 into IQR, na? So if you could describe that, like what is it that
I
will
said it is Q3 minus Q1. It's IQR.
Okay, so it's just a term for that value that we derive from Q3 minus Q1.
It is interquartile range,
Okay.
which is Q3 minus Q1. Third quartile minus first quartile is IQR. That means this particular, all the values coming here in the box, this is IQR. Because Q3 is what? From here to here, this is Q3. Q1 is from here to here. So if I'm subtracting from Q3 to Q1, that means this area is remaining, which is IQR.
Okay, ma'am.
Done?
Yes, ma'am.
So we can say this thing that there is no outlier available in the data. So that way we have checked the assumptions and all the assumptions are through or passed by our data. That means now we can apply the t-test. I think till here everyone is fine. May I proceed?
Yes.
Yeah. So you need to see there's a function called t.test, right? So firstly we'll see what this takes. You can use a question mark. Press Control Enter. This will show you what are the various parameters you can pass: x, y, alternative, mu, paired, variance, equal or non, confidence level, etc. Right? So these all are the parameters which we can pass, but it is not like all the parameters are mandatory to pass. With the few parameters also, we can run the t-test, right? So for one sample t-test, I am writing t.test. In brackets, you need to give the name of your variable, which is IQ, right? Now, I think from the problem I have written here, I want to find this thing, I want to check this thing, that this sample is belonging to the population in which the mean IQ is 100. That means population mean is what? It is 100, right? Or you can write mu equals 100. Is it clear?
Yes, ma'am.
And then you can run it. So once you will run it, you will get the output in the console. There you can find one sample t-test results are saying these are the values. Just a minute. These are the values. So these values are t value, whatever t calculated value which is coming from the formula is 3.9933, and the degrees of freedom is 19, right? Now you can find the p value is 0.000779. That means I need to take my decision on the basis of the p value. So can anyone tell me what I can conclude from the p value?
It will be less than 0.5.
Okay, p is less than 0.05. Yes.
So you will reject the null hypothesis.
We will not accept the null hypothesis, right?
Yes.
If I'm not accepting the null hypothesis, I'm concluding that there is a significant difference in the mean IQ of sample and population. That means sample mean is not belonging or not same as the population mean. Is it clear?
Yes,
I hope it's clear, everyone. Fine. So this way you can check or apply, or what I can say, test the hypothesis for the one sample t-test, right? Along with the assumptions testing. Now I'll talk about the second t-test, which is the two samples t-test. So two samples t-test means here we will be having two samples. Previously we was having the single sample or one sample. Now we will compare or we will having the two samples, right? So here there are two options available. First one is the independent samples t-test. So when I say independent samples t-test, that means here your samples will be independent to each other. They will be unrelated, right? So that means purpose will be to test the significant mean difference. Then second one is groups will be or samples or groups or levels, you can call them, right, will be independent or unrelated. So here the main important thing is that you need to know there should be two unrelated or there should be two independent samples, right? This is the important thing. Now you will compare the mean of your what I can say dependent variable. Means here there will be a concept of independent and dependent also. In case of one sample t-test, there was no concept of the independent and dependent. So here I can say this thing that there will be one independent variable which will be categorical and will be one dependent variable which will be continuous, right? So what we will do, we will check whether the dependent variable is same in two categorical categorical variable or not in the two categories, because in the independent variable we will be having the two categories, right? So here I am writing categorical variable with two categories. सेशन में हूँ. right? So you can say categorical variable, independent variable will be categorical, and it will have only two categories or two groups or two samples or two labels, one in the same thing, right? So you will check your continuous variable is same in two categories or not. This is what you need to test in the independent sample t-test, right? Now, talking about its assumptions. So the first one is there should be one IV, that is categorical variable with two groups or labels or categories. Or samples, one in the same thing, right? So here we will be having one independent variable, and in that independent variable there should be two groups. Second is there should be one dependent variable, that is continuous variable. Then next, third, the DV, dependent variable, should be normally distributed. Then fourth, or I can specify this in more better way, but DV should be normally distributed corresponding to the categories of independent variable, right? Next is there should be homogeneity of variance of dependent variable corresponding to the categories of independent variable. Then there should be no outliers in the dependent variable. So these are the assumptions which you need to test when you are talking about the independent sample state. Is it okay?
Yes, ma'am.
Done. Now we'll go with the example now. Suppose I am taking a very simple example. I want to compare. So I want to compare the marks of male and female students. Or I want to check this thing, or I'm writing, or to check the mean difference in the marks of male and female students, right? So this is what my purpose is. Looking at this particular example, can anyone tell me how many variables I'm having?
Ma'am, two variables, marks and gender.
Very correct. We are having the two variables, marks and gender. Marks is the dependent variable because it is continuous in nature, and second one is the gender with two labels, and it is independent variable, right? Now, firstly, we will make two vectors, right? So suppose first I am making for the marks. So I'm entering, suppose there is any subject and in which the assessment is done by the 50 marks. So on the basis of that, we will enter certain marks here. So out of 50, how much marks a student or the students were scored, we are entering that in this marks vector, right? So suppose I'm entering so at least 10, 15 to 20 entries we should make, I think, and that we will proceed, right? I'll enter and then I'll share in the chat so that you all will be having the same figures, right? Luckily, I entered without counting. I entered 20 observations. Okay. I pasted in chat. I hope you people have received it. Fine. May I proceed?
Yes, ma'am.
Now we will create the second vector, which should be a gender. So arbitrary, I am entering the values, right? Checking the length. I think it is not sufficient. It's 23. I have entered many. I need to remove last three. It's 20. So do I need to copy and paste this also?
Yes, ma'am.
Fine. Okay. So I pasted in a chat. Done? Received by everyone?
Yes, ma'am.
Fine. Now we'll check the assumptions. The first one is the normality one. Because first two, the regarding the type of variables, we have already taken the data accordingly. That means we are having the first variable, which is the marks. You can see this is a continuous scale variable. Second variable is the gender, which is categorical, and in this we are having only the two categories. Only thing we missed is we have not converted the gender into the factor variable. So how I can convert this into the factor? Because generally, if I want to make it categorical, I need to make it factor. So what I need to do if I want to convert gender into the factor? Anyone?
As dot factor and gender in the brackets.
Okay. Okay. Ashish sir, it is. Abhishek sir. Who said this?
Abhishek, ma'am.
Abhishek sir. Fine. Any other opinion?
Ma'am, we have gender, so basically in the function factor we'll pass gender and again store that in the gender factor itself.
Fine. Good. Both ways we can do. So I understand. I think I have a problem. So before this, right, I am entering factor. Then
Yes, ma'am.
you can find, right? Now, so we check both the assumptions here, first two. Now we'll go for the normality checking. So as I said, we need to write the hypothesis firstly, which is what? Which is marks variable is normally distributed. Done. Now I'm writing the function which is Shapiro dot test. Inside this, you need to pass the variable name, but you can read the assumption. I said the DV should be normally distributed corresponding to the categories of IB, right? So in both the categories, I need to check whether the marks is normally distributed or not. Means for the male and female, both I need to check marks should be normally distributed. Is it clear?
Yes, ma'am.
Fine. I think I don't know this will work or not, but I'll check. Probably this will work. No. Shapiro will not work like this. It will give you the overall normality like this. Yes. So we will copy this, paste this here, and what assumption we can draw from this? Anyone?
Hypothesis H0 is accepted.
H0 is accepted. That means marks variable is normally distributed. I'll do one more thing here. Shapiro dot test question mark. It is taking only X, right? Done. It is clear. Now, I'll check the normality using the QQ norm. I'll pass the name of my variable marks. Pressing Control Enter, you can see the figures coming in the Then now you need to use QQ line for marks and you can press Control Enter. And that way you can check. Now you can see looking at the diagram, we can say this thing that the variable or the looking at the QQ plot, we can say this thing that the marks variable is normally distributed according to the quantile plot also. Normal quantile plot. Is it clear?
Yes, ma'am.
Now we'll go and check the next assumption, which is outlier. For checking the outlier, you need to use box plot, right? Inside this, you need to pass the name and you need to use this tilde sign and you need to give the name of your categorical variable as well. Done. Done, everyone?
Yes, ma'am.
You can find this tilt before the 1. The key you can find in the keyboard, key 1, before the this means the very first key in the second row, very first key, and with the using shift you can access this tilt, right? Done? Created?
Yes, ma'am.
So for both the categories, that is male and female, you can see we are having the independent two different box plot. And looking at the box plot, we can say this thing that both the categories are not containing any outlier for the marks, right? So that means there is no outlier for the marks as well. Is it clear?
Yes, ma'am.
Now we'll check the homogeneity of variance. For this, you need to install a package named as CARE. Done? Done? You need to run this. I think I have already used this package. So it is already available. I need to only run the library function to bring it in the global environment. Fine, everyone. It is working. Taking time?
Yes, ma'am.
Okay. Once you are done, please tell me so that I can proceed.
Ma'am, it's installed.
It's done?
Noted. Yes.
Yes. Shall I proceed? Everyone? I hope I can proceed.
Yes, ma'am.
Yes, madam. You
Fine. There is a function called live-in test, right? Here you need to pass marks using the tilde gender. Done? Got it, everyone?
Yes, ma'am.
Now, I think you need to write firstly the hypothesis for the limit test. Whenever there is p-value involved, that means we are testing a hypothesis. So always there will be a hypothesis whenever we are getting a p-value. So in case of a limit test, it is variance is equal. Because it is homogeneity of variance, we want to see equality of variance of the marks in the both the categories of gender, that is male and female. Means marks should be the equal variance in male and female categories both, right? This is the meaning of this hypothesis or the assumption, right? So looking at the p-value, you can see the p-value is greater than 0.05. That means what I'll do?
Accept null hypothesis.
Yes, H0 accepted. That means I can say variance is equal for marks in both the categories of gender. Is it okay? I hope it is done. May I proceed?
Yes, madam. Yes.
Yes. So that means we have checked all the assumptions and our data has passed the assumptions. Now we will go and we'll check or we'll apply the t-test now, right? So firstly, I'll write the hypothesis. I think I haven't written the hypothesis of t-test here, right? Yes. So here the hypothesis of the t-test will be there is no significant difference in the mean marks of male and female students, right? This will be my hypothesis. Is it okay? Fine.
Yes, ma'am.
So our test results will be, on our test, we will apply using the t-test. Here I need to pass the name of my dependent variable. Using the tilde sign, you need to put the categorical variable. And one more thing you can put here, which is alternate